Hello. I think you can hear me. Just double check. Okay, I will start then. Um, Thank you very much for this opportunity. As a medical care, healthcare, we are working on Radizac and accurate cooperation. And today we would like to show you new tomotherapy machine, which is Radizac, and explain its details. And before we start, I would like to introduce first Medical Healthcare, and we are a company in radiation oncology, almost 37 years, and we have so many also radiology and radiotherapy departments, and also PPT projects as well. Anyway, let's go through the Radizac machine. And before we start the presentation, we always like to show you the results because we think it's the most important part. I will show you the first treatment spectrum, which is the most important result as we discussed. As you can see, we have a very long treatment area, and craniospinal, TMI, TBI, and we have and I will show you in details. Sorry, my connection, I guess. So, if you look to tomotherapy systems, its evolution is start with the Rat Maki. It's the founder of the and designer of the tomotherapy medical physicist. And 2003, we started with the Hayat, and then Toma HD came, and Toma Hair series came around 2013, and now the newest technology of the Accuray is the Radizac. So what is Radizac actually? Radizac basically better and faster tomotherapy, and also it has tracking feature from the CyberKnife. So as you can see, it's a combination of two high-tech machines. Now it's better than tomotherapy and also features from the CyberKnife. And I will show you a movie, a short movie, how the Radizac treat lungs.
Ondan mesaj atar mısınız? Bugün hemen tüm bakiyeler neyse işte arkasınlar ifade en azından bir jest olsun. Laf etmesini ya şey yapmak.
Tamam.
Devamında salı pazartesi. Yani salı sakat.
Horun'un hesabı var orada değil mi?
Var. Alman'ın da var.
Tamam.
Ama Medik'te zaten boş hesap var.
Tamam.
En azından bugün yapsınlar havaleleri. Sonra da şey başlatacak. Bir de roman da yazarız. Roman şey yapsın. Bu sözleşmeleri başlatsın.
Now system start to treat, and as you can, it's tracking. As it moves, as the tumor moves, the machine also moves.
Anılarla konuştu. Kasti başkanı.
Bir şu şeyi dinliyoruz, şu bitsin. Ondan sonra Bora'nın sunumu. Yarım saat sonra.
Tamam.
Okay, let's continue. This is the general information of the Radixac, and the bore is 65 cm, so it's kind of big bore. Patients don't feel like claustrophobic because it's such a big bore, and also the treatment area is just front of the gantry, so patients don't go that much inside. And uh, I like to emphasize on what is unique on Radixac. You know, it's completely different and looks, and also not only design, and also how to treat the patient. But the first unique feature of the Radixac is long treatment field. You can treat up to 135 cm longitudinal and 40 cm on lateral. This is the most, I mean, this is the largest treatment field in the industry. And as you can see, if you can treat like 135 cm, it's easily the craniospinal one plan, TMI, TBI, and such a treatment feels just one setup and one plan, and it's so easy. And the second unique feature of the Radixac is ultra-fast binary MLC. And when we say ultra-fast, it's really fast. I will show you in detail now. As you know, the most important component of the Linux is MLC. And what makes better MLC is faster MLC is better, and also thinner MLC is better. How about the Radixac MLC? How fast if you compare to conventional MLC? Because we call it ultra fast. For example, 2 times. No, this is Versa HD and the Varian machines. They are 2 times faster than conventional MLCs now. But the Radixac, even not 5 times, not 20 times, not 50 times, exactly 100 times faster than conventional MLC. And if you compare to the other high-tech machines, it's 50 times faster than any other Linux. So it's, if you have faster MLC, it means that you're gonna have more modulation. So this is the real video of the MLC movement. As you can see, sometimes we can even, it's a blink of eye, and it opens and closes within milliseconds. Milliseconds to open or either close. The MLC thickness is 6 millimeter everywhere. So from left to right, everywhere is 6 millimeter. Not on the center, it's everywhere 6 millimeter thickness. And it's called binary mode because it's completely different design, either open or closed. It's not like the other MLC type 4040. This is very small MLC because it only modulates very tiny area. As you know, Radixac and tomotherapy machines treat slice by slice, as if like CT imaging. We CT imaging slice by slice, but the treatment is the same as well. So the Radixac treating slice by slice. So the only field on the longitudinal area is the just 1 cm or 2.5 cm. It's up to you during the treatment. And 40 cm on lateral, all the MSC is side by side here. So it's quite fast. So if you compare Radixac with the other arc treatment machines, it's a little bit difficult to compare, but I will try to explain in simple way. So basically, Radixac, both are the same treatment. Let's suppose they are the same treatment, and we start to treat the patient, both system, Radixac and the IMED, which is arc treatment, could be Electra, Variant, doesn't matter. They start to treat the patient at the same time. Now we are treating. And both systems, I'm going to use the 360, so there is no much difference from the angle view. But let's stop anywhere, any angle. And let's suppose I stop 30 degrees. I click and I pause here. Now, some part of the MSC are closed and some part is open. Open part receive the same dose, closed part receive 0 dose, right? From this angle. Of course, there is going to be another angle, but we're going to talking about now this angle. And there are 2 contrasts right now, black and white. open place receive same monitor unit all around, and we can call it black contrast, and the closed area receiving 0, so we call it white. So we have two contrasts, black and white. But if you look at the Radixact treatment, first of all, we treat slice by slice, as you can see. So we are now with the first slice, and exactly the same angle I'm stopping. I stop here, 30 degree. And Radixact machine can spend 1 second, one angle. 1 second is such a big, long time for Radixact because it means 1000 milliseconds. It can play with the opening time of the MLCs. So it can tell this MLC to be open like 500 milliseconds. This one 400 milliseconds. This one 325 milliseconds. This one is 50 milliseconds. So each individual MLCs has different opening time. So it means that each individual MLC has different dose, different monitor units. So rather than black and white, we have 200 black and white gray tones between the black and white gray tones, and you can give any MLC this gray tone. So we have more contrast. So we can assume that in radiotherapy, the purpose is to paint the PTV homogeneous. If we think of those as a paint or color, we like to paint the PTV homogeneous and no color on the organs. Of course, photon has an exit and entrance dose. It's not possible to without no color organs. But imagine you have a pen and you have 200 different contrast, black and gray pen, and you can touch anywhere you like this. You can touch anywhere, any gray tone you can give. But in the other Linux, you only you spraying the color, and you have one open place and you spray here all the same color. There is no contrast anymore. The contrast gonna come from other angles. If you add the other angles and other other segmentations, then you're gonna have IMRT. But right now, without changing even the angle, Radixact has 200 different IMRT intensity modulation. And another feature of the MLC, I'm telling more about MLC because this is the most important part of the Radixact. This is what makes Radixact different than the other Linux. So another superior feature of the Radixact is that normally you cannot bring any MLC like this in the middle. So like to protect something in the middle, you have to put something, like something. MLC is supposed to be right here, but conventional MLC design cannot, provide this feature. This MLC has to go there and it has to block here as well. So this is something Radixact can do actually. How it can do? I will show you right now. And the blue is the PTV. The orange orange one is the organ we would like to protect, and it's inside the PTV, not on the surface. It's inside the PTV, and we like to protect it. And if we have a conventional MLC, what we can do, take this MLC up to here. Now we protect the organ, but also we close to this area of the PTV. The better solution is only block the ROI and keep open here. So Radixact can do it. How can do it? If you on this slice, these 3 MLCs will be closed. Now ROI completely blocked, and these 4 will be open for the PTV. So as we discussed, we can do this. Conventional MLC design cannot provide this kind of protection, but the Radixact MLC design can do this. And there is a small movie about that. Just 2 minutes, I will show you. This is a conventional Linux treatment. As you can see, there are 3 organs, 1 on the surface, 2 on the inside of the tumor. Now, conventional Linux treating this, you can protect the surface one, but the critical structures inside the PTV will receive most of the dose. If you like to protect those one, you will miss the PTV coverage then. But for Radixact treatment, as you can see, Anywhere where the organs, the MLC will be completely blocked, and no direct beam will go through those organs. This is the second most important feature of the MLC. So, what is the result then? If we have 100 times faster MLC, and we have a blocking advantage of, just show you this one. And so, what is the result? This is the real dose distribution of the Marie Curie, which is the most known scientist, one of the scientists. And if you get the dose distribution with the Radixact, you can see how the dose can be shaped. You can shape the dose some degree, of course, with the variant HD 120 MLC, but you and the imaging field. Normally, if you have the combeam, you can
tipi ne acaba?
only like 20 or 30 or 40 cm imaging field, but with Radixact machines, you have more than 1 meter. And image takes only 1-2 minutes, and you can choose the slide thickness as a normal CT, 1 or 3 millimeter, doesn't matter. And the dose you're gonna give the patient, additional dose, only 0.5 centigrade. If you compare the fractional dose, which is 200 centigrade, is so tiny. It's just 1 out of 400. So nobody take into account this dose. But if you compare the combeam CTs, other linacs too, it's really high dose. It's up to 5 to 10 centigrade. So this is another thing. And all the IGRT images actually can be used for planning because this is real CT. All the image you take, real CT, and can be used for plan. So this is the real image of the, as you can see, everything is visible. And even the 1.5% contrast differences you can see. This is how good the imaging of the Radixact is. You can see even the smallest tiny contrast differences on the image. And if you in Linac combeam CTs and the Radixact CT, as you say, the most important part is the lowest dose. Lowest dose is the additional dose we give the patient, which unnecessary and we don't want it, right? And it's a 0.5 centigrade. And those calculation, we can use the IGRT images for plan, for Radixact, yes, but combeam CT, no. Imaging left is, as we discussed, is up to 130 cm, and for combeam CT, other Linacs, it's reached 28 to 40 cm, and also accuracy is much better in Radixact. And another unique feature of Radixact is automatic adaptive. Adaptive, as you know, means during the treatment, patients sometimes lose weight or some anatomical change. And due to these changes, dose distribution has to be changed. And we have to know how much the dose change, and we have to take, new action, maybe new planning or something like that. These things take so much time in radiation oncology. But Radixact makes it so simple and make it automatic adaptive. So how it does it? Basically, all the IGRT images taken day by day can, as we discussed before, can be used for dose calculation because they are real CT images. And every day on the background, after patient has been treated, system on the background start to calculate the dose. And this is the dose of that day because we have a new image, new anatomy, right? If the patient lose weight or gain some weight, doesn't matter, the dose will be changed. So it calculates how much dose will be changed every day. And calculate every day, every day, and let's suppose today the 13th of day. And one click, when you click the automatic adaptive, it gives you the report. And this report is very simple. It gives you the exact dose of each organ, even PTVs and organs. If you see any red, it means that it's about the constraint. So you have to take action. For example, Paratis initial plan says is 29 gray. It's less than 30 is green. This is the initial plan, the first plan, first day. After 13 days, now it's showing that right parotid will receive 35. And it put red cross here because it's more than 30. So we know the exact doses each organ will receive right now and how much will receive in the future. So you can take action. You can decide, okay, let's do new plan. Let's adapt the plan. Or you can say, okay, this does not much. Let's continue. Let's continue. It's not going to be so much side effect or something like that. You can decide and just one click and you can see the real dose of the patient. And after that, the adaptive is going to be so simple. If you decide to do the new plan, all the contours will be transferred to your new CT, and everything is automatic. Basically, all you need is to check maybe a couple of minutes if the organs are correct or something like that. Everything is automated. And another unique feature of Radixact is very user friendly because it has an automatic contouring. Actually, most of the systems right now have automatic contouring and deformable fusion, but these are standard in the Radixact. And the treatment console of the Radixact is so simple: just one computer, one console, and nothing else. If you compare with the others, it's too much complicated. Training is too hard for it. Maybe so many times take to train the therapist. But for this system, only 1 hour enough to treat the patient. The training takes only 1 hour for the therapist. So because it's so simple and one computer based. And let's talk about the time as well, and how beam on times and IGRT times and in general. If you treat 8 hours, you can treat 48 patients with Radixact, and all of them will be IGRT and IMRT. So it means that each hours you can treat 8 patients. All of them will be imaged. All of them will be treated. But we don't put any time border or something like that. You can put some shifts and you can even 16 hours. And if you manage to treat 16 hours, you will end up almost 100 patients every day. And the planning also so fast. This is not beam on times, by the way. These are the times medical physicists spend for planning. So imagine medical physicists will spend only 9 minutes to generate this plan. So also planning also so fast in Radixact. Let's talk about another time process, installation process. And it takes normal Linux almost sometimes like months, couple of months, 3 months, even sometimes longer. But in Radixact, installation takes only 10 days, and the machine already beam data inside the machine, so you don't need to collect the beam data or anything. All you need to do just 2-3 days QA and test, which is acceptance test, and after 14 days, around 14 days, everything is ready, and you can start the trade. Of course, you need some licensing issues and with each country, but for the machine to be ready only takes 14 days. And another really good thing about the Radixact is, as you know, technology is good, but there is something wrong with the technology. What is wrong with technology is it gets older. As you get older, it's not it's not a new technology anymore. For example, if you buy this phone 10 years ago, it was the best phone at the time, but now we have this one and nobody using this one after 10 years. But this is not the case for Radixact. If you buy this Radixact today, after 10 years later, you will have the newest Radixact as the upgrade. We are not going to take this machine out and put the new one. But the way all the upgrades come, all the new machine comes. It's designed this way to put the old machines as well. So with the low cost, you can make your old machine to the newest one. So your Radizak will be never old. After 10 years, if there is a new technology or something, you pay maybe 10% of total cost, and you're gonna make your old Radizak exactly the new Radizak or new machine, whatever the actually will come up with the new machine. So none of the Radizak will be in the rubbish in 20 years or 30 years. But the other Linux, that's the case. For example, if you have DHX, variant DHX, after 10 years later, now variant Turbine, you have to take, throw the DHX and buy the Turbine. This is how the system works. But in Radizak world is not the same. After 10 years, you just do the upgrade. That's it. And it's low cost upgrade, and your machine will be exactly the new machine. And also uptime quite high. We reach 99% uptime. It means that the machine is very reliable. It doesn't break down easily. So now I will talk about the treatment spectrum, what we can treat with Radizak. It can treat anything actually. You can do SRS, SPRT, IMRT, or 3D conformal. And it's the largest treatment spectrum because it has also larger treatment area, as we discussed, more than 130 cm. And it's, as we discussed, everywhere you can treat. Let's talk, I will show you first SRS. The smallest tumor you can treat is 0.6 cm, which is the reasonable for SRS, minimum. And our dose gradient for SRS quite well is reach 100 dose to the 50 within 4.5 millimeter. So it's adequate SRS machine, but this machine is better for IMRT. This machine is perfect for IMRT and the best machine for IMRT. And this is a very simple example of that. As you can see, whole brain treatment, boost on the metastasis, and also hippocampus sparing. And we can spare this hippocampus because, as we discussed earlier on the MLC part, we have blockage. We can block any organ, any angle, so that we have this kind of dose distribution. And another example of that, as you can, this is spine treatment. Is something around the spine, and we like to protect the spine. And as you can see, there is no dose, direct dose to the spine. Of course, there will be some dose, some scatter dose, but there is no direct beam passing through the spine. For head and neck cases, it's regarded as a gold standard, as you may know. This is one of the red journal papers in France. There are 13 clinics joined this paper, and they compare some treatments with rapid arc and some treatments with tomotherapy. And in the end, they conclude that tomotherapy had a better local control and better cancer-specific survival than rapid arc, and side effects less than the rapid arc treatment. And as you can see, this is the local control is better on the tomotherapy, 33, and 72 for the variant rapid arc. And this red journal shows how superior the Radizak is if you compare to other arc treatment. And as we discussed, we have a longer treatment field, up to 130. So chronic spinal is just so simple plan for tomotherapy role. There is no need to junctioning effect or anything, just one setup, one plan, and it's IMRT. For other technologies, you have to, junction maybe 2 or 3 times, and there is a cold and half point issues, but there is no need for tomotherapy. Tomotherapy, Radizak also really good options for the bilateral chest wall treatment and also breast treatment. By the way, Radizak during the treatment, it rotates, continuously rotates. It's like arc treatment, but it also has some Linux inside. So if you like to do conventional treatments, like, if you like the tangential treatment, you can do this with the TomoDirect feature, which Radizak has. So it doesn't need to be rotate all the time. If you say the system, stop here, stay here, and rotate. That's it. So whatever you do with the normal Linux, actually you can do also with the Radizak machine. This is the example of that. But from the angle, it comes with the organ protection. But as you can see, very homogeneous PTV dose. This is the advantage of the Radizak because we have 100 times faster MLC. Even the same angle, we can use this faster MLC feature and we can get more homogeneous dose than the other machine. So your PTV is gonna be always look like this, very straight, very minimum low dose and very low maximum dose. And this is helical IMRT breast. It also has a boost 60 Cray boost. Although it's left breast and it has a boost 60 Cray, and you can see the left lung doses. This is the left lung, and V20 is 10 percentage, and V5 is 35. Normally, V5 is supposed to be very high for IMRT work, but this is the Radizak how it treats. It doesn't use always all angles. We block these angles from bottom, as you can see. We only open these angles, and also we close the exit those these angles as well, so that we block the exit those to the organs. So basically, even the helical IMRT breast treatments will be superior to if you compare with the other machines. There is a MD Anderson joined with the Koreans one paper, and it's the estimation risk of secondary cancer risk for breast treatment, breast patients, and in the end, they came to conclusion that tomotherapy is a better modality for younger patients. So because the secondary cancer risk is lower because the integral dose is lower if you compare. This is another dose distribution you can get with the only Radizak. This kind of dose shaping you can only get with the Radizak because as we discussed, we can block to anywhere. If you have a like surrounded or the donut shaped dose distribution, this is the machine can do it actually. And the mesothelioma treatment, as you can see, we can protect the inside the lung. This is another lymphoma treatment, and it's a really large treatment field. But as you can see, the lung sparing the lung, TMI, and also another TMI and TBI. This is TBI with the lung and also optical organ sparing. And also anal canal. How difficult is the? I mean, if the PTV is irregular shape, it's better for the Radizak. So Radizak is actually likes the most difficult cases. So irregular shapes, it's more simple for Radizak. And superficial treatments, it also is very successful for superficial treatment. As you can see, this is scalp treatment. And how it comes with this feature, because it doesn't have electron, it's very simple because it uses only tangential beamlet. Like as you can see, it uses this angle, and the beam goes like 5-6 cm in the scalp. Rather than if you use this angle, straight angles, the build-up region will be in the PTV. This is uncertain. It means uncertainty. Also, you accumulate the dose inside. So the system automatically decides tangential beam so that it goes more on in PTV, and there are less uncertainty on the dose calculation. And also one example as well. This is second radiation of the patient. First treatment was here. So before the second treatment, they say the system no dose to here, completely blocked. So as you can see, now this area will receive only scattered dose, nothing else. And this how the Radizak can shape the dose. This is the end. Thank you very much for your time. As we say, this is the most important part. Rather than show the machine or something, the clinical results. And this is the clinical result of the result. Thank you very much for your time, and thank you very much for this opportunity.
Thank you.
If there is
Very
any,
interesting lecture.
if there is any question, I can try to answer.